Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. So as part of machine learning, you need to understand some important data structures in Python. And one of these data structures is a dictionary data type. So here, what you can see is a dictionary. And how do we know it's a dictionary? Because of these curly braces. So here, you've got these curly brackets, one over here, one over there. That's one of the methods to recognizing a dictionary. But there is one additional thing that you need to recognize if it has a key and a value. So what you can see here is this is data structure within a data structure. The lists are defined by these square brackets. So this is a list of items within a dictionary. So here we recognize the dictionary by these, but the additional part is they must also be in this format, which is a key. So this size is the key and the value is a list. And the list has the following items in it. And the same here, this is the second key now. So that was the first key and we've got bedroom as the second key. And it also has a colon to separate it. So the colon separates the key against the value. So the colon is another indicator that you are looking at a dictionary. So here, bedrooms contains a list of items. And the way you recognize the list is by these square brackets. This is a complex data structure because within it, it contains another data structure called list. This is a dictionary and the dictionary contains a list within it. But remember, these are the keys. Keys have values. So normally you might only see one value. So something like this, you might see it in this format. So it might have 2 bedrooms and the price may be 200 over there. So this is what you would see. So in this simple example, you see a value and the key, a key and a value, a key and a value. And this is a simple data structure because you know you're only dealing with a dictionary. And dictionary is just like a dictionary that we're used to. It has a word and its meaning, a word and its meaning, a word and its meaning. So the same concept applies in Python. This data structure by these curly braces means you are looking at a dictionary. But remember, it can easily get complex. As you can see here, you can actually have, for the values, you can actually have a list of items. So this is important to understand in machine learning, as you will come across these kind of examples many times. So as you can see here, we discussed previously that this is a dictionary data type and the dictionary has a key and a value separated by this colon. So wherever you see a colon and a curly brackets like this, then you know that this is a dictionary you're looking at. But the dictionary values, so that's a key and that's a value. This value is actually a list of numbers in here. So what you can see is when we convert it into a data frame, so at this point, this is a dictionary, but we convert it into a data frame. And what we mean by a data frame is essentially a table. So if I were to run this piece of code over here, and if I print this data frame over here, so if I print this data frame with the print keyword and the data frame within here, what you can see is we brought the index values here, which it has created internally. So these are like the unique row numbers, you could say. And here you've got the columns. So what has essentially happened is the dictionary, which had size, bedrooms, and price, these have become columns, as you can see here, size, bedrooms, price, and the values, which was a list is defined by these square brackets. These have essentially over here become rows. So you can see this has become a row and over here and over here. And the way Python has converted this is by using the pandas module. So PD is the module here, pandas. It's a very popular module and it takes in this dictionary and converts it into a data frame, which is essentially a table. Now, one important thing that I can highlight to you is if I were to delete one of these values, so it gets misaligned. So now there are not enough values in here versus the other list items that we've got here. So we are one short over here. And what you can see if I were to run this is you get an error message to say that there is a value error. So here it's saying mixing dictionaries with non-serial may lead to ambiguous ordering. So here all arrays must be of same length. So it doesn't like that. So if you accidentally miss something, then you will get that error. So if I put that back in and all the values are there, it is able able to align all the items. So it's able to align the first data row here with the values that you had here. So 650, 2 and 200, 650, 2 and 200 over here have been aligned. That's how a dictionary is converted into a data frame, even though it has a list of items as value for each key. So here you can see we created a data frame, but how do you only select 2 columns from a data frame? So in machine learning, this is quite common, where you only need to select certain features. So here we want to select the size and the bedroom because the price is going to be actually our y-axis. So how do you select that, and what does the syntax actually look like? One important thing to understand is we are creating a new data frame from an existing one. So this df here is defined here, and we create a data frame by using the pandas gd, and then we use data frame here and pass it our data. So our data is here over here, which is a dictionary. This is the key, and the key had the following values, and these keys are converted into columns. So these are 1 column, 2 column, 3 columns. So as we see here, we go converted into columns over here: size, bedroom, price, and the rows are actually just the data of list here that we have. Remember, the length must match for lists. So here the total number of items must match in each list over here, otherwise your code won't work. So if we do that, so if I just take out one of the values, and as we saw previously, we got an error because the error says that they must be of the same length. So what it means is by the comma separated list here, you must have the same number of items in all 3 columns that you have here. So going back to the selection of data frame, so we had the original data frame, which has, if I run this code again, you can see it has 3 columns, and we only want to select the size column and the bedroom column. What we do is we create a new data frame here. So we got to call it X and use the existing data frame, which is over here, which got generated by this data over here. We've got that, and what we're going to do is we've got our size and bedroom, and notice this is a list. So you cannot simply take out these square brackets because this won't work. If I were to run this, you will see we got an error. It says key error. The reason it's a key error is saying there is no key called size and bedroom because we've got to separate them out. So size and bedroom are 2 separate items. So you put them in a list over here. We saw how lists work. So here we've got a list of items. Notice how they are comma separated, and the same rule applies here. If you want to select 2 different columns, then you need to separate them out using a comma and put them in these square brackets, and then that would give you a data frame. So if I were to run this over here, you'd have this data frame over here, which will only contain the 2 columns, and we can see that by printing it. And as you can see here, originally, so now we've printed using print and the X over here. So if we look at the original one, had 3 columns, 1, 2 and 3, but in the new one we only have the bedrooms and the size because this is what we said we wanted. So it's important to understand how to create a new data frame by using an existing data frame and selecting only the relevant columns. So continuing to look at some utility functions that will be useful in your machine learning journey in Python. With your data frames, what you can do is you can print the data that you see. So previously we printed the data frames using our simple print statement. So here we have a simple print statement versus this print statement over here. So the differences, as you can see, are by using this print df head, what it's automatically going to do is rather than print everything. So if you have, for example, thousands of records, you don't want to print everything. What you can do is you can use your data frame name over here. So that's our data frame over here that we defined, and it got created by this. And we will now want to print this. So within the print statement, you can say data frame variable. So that's a variable name, dot head, open parentheses, close parentheses. And what you can do is you don't have to reuse this toString method. So if I create this bit over here, you can actually just leave that bit out, and we can see the all 3 different formats for this one. So if I were to run this, what you will see, the first one will look like this. So you can see it looks like that. The second one looks pretty much the same. So if we have a look at our code here, so what we did was the first one has this toString method. And what you can do is you can show the indexes. So indexes are the values on the side here. So you can see this is the index number over here. But with the toString method, as you can see, you can change now to false. And now if I were to run this again, what you will see is in the print, the first one that does toString, the indexes have now disappeared. Whereas if you were to not use the toString method and just use print head, then it will always print the indexes. So the reason for having this toString is it converts it to a more presentable format, and you can then customize it to your liking. And the final one, of course, was print DataFrame. What that does is prints all the records in your data. So here you can see if I were to, the first one printed only the 5 elements, but the next one printed all 9 of them. So here we have all 9 elements being printed, whereas previously if you use the head function, then you can see that you only get the 5 elements starting at 0. So this is important to understand why we use head. And you might be wondering, how do they know 5? It's because if you hover over that, you can see that the default value is 5. So by default, if you don't tell it what n is, it will use the first 5 elements. So here in machine learning, we selected 2 features, which is the size and the bedroom. So basically we selected the 2 columns. So in our original dataset, we had size, bedroom, and price. But what we did was later on, we just selected that we wanted to just do calculation on the size and bedroom. The reason to exclude price is because price is what we are trying to predict. It is not a feature. So when we selected this, as you can see, we used the square brackets over here because we wanted to pass 2 values, which is a list of items. So we wanted the size and the bedroom. So these 2 columns are separated by a comma, and they have to be in these square brackets. This is because, as you know, list items are always in square brackets and are separated by commas. So it's the same concept applied here. And this gives us a data frame. So you cannot, for example, remove this over here or do it in this fashion. You cannot remove the square brackets. That's not allowed, and your code won't work if you do that. So if I were to run this, you can see we got the error, and it will not work because it's saying that it cannot find a key, which is size and bedroom, because it needs to be in a list. So we just want a list, like a shopping list. We want to select 2 columns. So just as with a shopping list, you need to put it in a list. You cannot do without a list. So the next one is when you select a single column, you actually just put in the column name. If it's a single item, then you do not need to put it in a list. So here you can see we just want y variable here to be the price. So you only put in the one item and you don't need to put it in the list. So you don't need to actually do this. Although if you do this, then it will still work and you won't get any errors. So if you were to put square brackets in, there is no harm, but generally you may see code like this without the inner square brackets. So the outer square brackets always be there, whether you're doing one item or 2 items. So here we did 2 items, but here we're doing 1 item. The outer square brackets always remain. It's the inner ones that you can remove, because there's no point having a list of items if it's only 1 item. So that's how you do column selection in machine learning, where you just need to select 2 features and then you just separate out your data frame, essentially the table of the data. So where you have a situation where you got data in 3 columns and you only want to select 2 of them, then this is the method to do it by using your existing data frame, square brackets, and supplying a list of items that you want, or it can be a single item like this. So you might think in Python everything is a data frame. That's not necessarily true. So here you can see that we created a data frame for our machine learning. So essentially this was our data. It was a dictionary that contained keys and value. So each key has a value, and this value is a list of items. So remember, lists are just comma-separated items that are contained within these square brackets. And then a dictionary is recognized by these curly braces and the colon over here. So this colon and the square brackets, when you see them, you can assume safely that it's a dictionary. So we converted that into a data frame. But later on, when we selected the features, so we selected size and bedroom, so these would be our features, okay? But what you'll notice is we also separated out the price. So the columns that we got essentially were originally like this: size, bedroom, price. When we selected the size and the bedroom, it became like this. So essentially, so it went from the 3 columns here to 2 columns. Now, one thing that I want you to notice is that this generates a data frame. So this is a table essentially, while here, this isn't really a table. When you select just 1 column out of your existing data frame, that becomes a series. So here's how you find out this. So this here, you can see we've got 2 columns here. This looks like pretty much a table, but But when you look at the Y variable where we just select the price, this only has one column. And this one column over here, you can see that it doesn't really have a column name. It just has indexes over here, unlike this one, which has column names and indexes, and you've got the values over here. This one just has the values and index. So this looks like a list, but it isn't a list. Internally, it's still part of pandas. So what you can see here is we have the X one is actually a date frame. So the X variable, because it has two columns, is a date frame, but the Y variable over here is actually a series. And all that means is that a series is one column and it has indexes over here. And I'll explain what the difference is between a series and a list in another explanation. But for now, it is just easier to understand that if you have two columns, then it'll be a date frame. If you have one column, then it's a series. So this series is created automatically by Python. So when we did this syntax and used this syntax, this created a series, while this one created a data frame. So understand the data types that you can have in Python. And as you can see, it can be quite difficult for beginners to understand the different data structures in Python. What we can do is we can break this down. So how do you know what this is? When you see two curly brackets over here or curly braces over here, how do you know what this is? And you see this colon, and you see the square bracket, how do you know all this? So let's break it down. If we have a look, these are the main data structures in Python. So you have a list, a tuple, a set, and a dictionary. So let's see what this is by just looking at the details over here. We've got square brackets. Square brackets is a list, and this is an example. So if you have items like this in a square bracket, then this is a list separated by a comma. And you can see here, what do we have here? So we do have the square brackets over here, and we do have items separated by commas. So this you can say is a list, but this is within these two curly braces over here. So what does that mean? So if we have a look at the next one, we can see these brackets, which are parentheses, are tuples, and this is how they work. So over here, you can see if you have this round parentheses versus square parentheses, then it's a tuple. It pretty much everything else is the same, comma separated, but it's a tuple. And then you have these curly braces, and these curly braces now actually have comma separated items. So if we go back to our code over here, well, we do have the curly braces here, but we don't have comma separated items. Yes, we do have comma separated items here, but that's a data structure within a data structure. So this over here up to here is a data structure, but we do have commas here, but we also have these weird colons. So let's look at the next item. Next one says, which is if you have the curly braces with colons, then it's a dictionary. So let's try and understand that. So here we do have the curly braces. We have something over here, then a colon, then a value, then a comma, then something else over here, and a colon and a value. This is known as key. So the first part before the colon is known as key, and this is known as value. This is known as key, and this is known as values. And these key value pairs are separated by a comma. So if we go back here, and what you can see is we have the curly braces over here. We have the size. So if we go back to the example we had, so we've got something, a key. So these would be known as keys. And after the colon, we've got values. So those values don't have to be single values. So they don't have to be like, just one value. So it might make more sense to you if you just have this, something like this, then or something like this, then this looks pretty much like the structure we have here. So we've got a key and a value, But what you can do is rather than having single items, you can actually have multiple values. So you can actually have a list as its value. And that's how we recognize this data structure as a dictionary, because it matches the definition here. We've got curly braces and a colon, and we've got comma separated items over here between the key and the value pairs. So remember this in summary. So if you have square brackets, then it's the list, and it would look like this. It would be in square brackets, comma separated, tuple with round brackets and comma separated, and you've got the curly braces here that don't have a colon. So if you don't have a colon in here, then basically it's a set. So let's have a look at this line over here, which looks a bit strange. So here, what we have is multiple variables that are listed over here to the left of the equal sign, and our train test split function is being passed these arguments. So we are being passed x, so we're passing x, y, test size, random into this function. So that's the function being called. And normally you'd say the function returns only one value. And that is still true. It still returns one value. But in this instance, it's working as a tuple. So multiple outputs are generated from here, and those outputs are populated over here to the left of the equal sign. So the equal sign is here, and these variables are being populated. So this function actually still returns the single item, but multiple values are being returned in that single result. So if we have a look at the data types in Python, you could have a list. So it could return a list, and although it's returning one item, but that list can have multiple items in it. And so does a tuple. So although a tuple, you can see the single variable being returned here, but actually it can contain multiple items. And this is the same concept that applies. Now, one thing that Python does is it can have assigned multiple items. So here you can see that I have the equal sign and I've got multiple items. So this here is a tuple and is populating in that order A and B. A is being assigned over here. So 1 is being assigned to A and 2 is being assigned to B. So if I were to run this, you can see the output that we get. The output that we get is A is equal to 1 and B is equal to 2. So going back to this example, you can see 2 items. So essentially, you could say this is a bit like that. This is a tuple and this would still work. And you can see here the values got assigned. So you can ignore the brackets, but essentially it's doing the same thing. So the same thing is happening here. It is actually returning multiple values. And what Python is doing is it can do multiple assignments rather than single assignment, but they need to be in that order, because if we switch the values here, B and A, for example, then we would get a different output. B would simply have 1 and A would have 2, which is not what our intention was. So just remember that this is done by the power of multiple assignments in Python. So one function still returns a single item, but then Python has some clever tricks in its sleeve, which is able to do things like this, a single item being assigned to multiple. So here, as you saw, we could create this as a single item, a tuple, and this tuple gets assigned to 2 variables over here in that order that we specify. So B gets 1, A gets 2, or we could swap this around and say this is A and B. So it will be this one will assign to that, this one will assign to that. So if we have a look at the documentation for the train test split, it can be quite confusing as to what it returns. So if we scroll down this here, you can see that the output that we get is over here. So it says that it will return a list, which will be length equals 2 times the arrays. So here, what's happening is, since we are passing in X and Y, it will multiply X, which is 1 element, and 1 element here. So this will get multiplied. So there are 2 elements. So 2 of them will multiply it by 2, which gives you 4 items. So essentially you can think of a 2 times 1, 2 times 1, add them together, and you will get 4 items. Now the ordering does matter. So X train is X test here. So the first one returns 2 elements, and these are over here. There's the positioning matters. So if you put Y over here and Y test over here, you're going to get the outputs from the X one, which is not what you want. So the ordering does matter. So if we have a look at, for example, this example, the more basic understanding, you can see over here. So you can see over here, we've got multiple assignments. So if I were to put this into brackets, so multiple items being returned, and if I were to run this, you can see that A has the value of 1, B has the value of 2. So if you were to switch the ordering of this so that B is over here and A is over here, you are going to get different outputs. So A now gets 2 because it's over here and 2 is over here. So the ordering, that's why it matters within this code over here, because your X is over here and Y is over there. So you need to make sure your X is over here and Y is the second part over here. So the function internally basically returns 2 items. So you can see here, for example, get coordinates. That's the same smaller example. So as train split, so here we just got get coordinates. Get coordinates actually returns 2 elements over here, or tuple. You can put these brackets over here if you want for clarity, but essentially it returns 2 items. Those 2 items get allocated over here. So the first one is X, so the 10 would get allocated over here, and the Y would get 20. So you can see that the output is X in the word 10, which was the first item returned, and Y is equal to 20, which is the second item. And this is just happening, the same thing is happening with the train test split. It is returning multiple items, and those multiple items are being assigned assigned over here. So it may look like some weird syntax because on the left side of the equal sign, you've got multiple items. It's because the function returns multiple items, just as it does with the smaller example, which is I get coordinates, it returns 2 items, and those 2 items, as you can see here, get assigned 2 items on this side of the equal sign, get assigned from the values returned by the function. But the value returned is just a single value. It's actually a tuple data structure that gets returned.